Let's say that you are coaching a basketball team. And you have 12 players. Now you can start 5 people. Let's just assume, for the sake of argument, that any of the 5 starters can play in any of the positions. You're just going to select 5 people from your basketball team. How many starting rotations can you have? Well, one way to look at it is to create a word, so to speak, with what we have. We have 5 starters, and then the rest are on the bench. And so that could be one way of picking your 5 starters. You just select the first 5 on the team. Now we want to figure out how many ways can we rearrange these letters, just in the same way that we did with Mississippi and statistics. We're going to take our 12 factorial here. We're going to divide it by the 5 S's that we have and the 7 bench warmers. This will give us the number of combinations that we can have. So here I'm going to do 12 factorial. I'm going to divide that by 5 factorial and 7 factorial. I'll get 792 combinations. Now, this actually happens a lot in this format when it comes to mathematics, and as I said before, mathematicians will try to find a shortcut. So we have something called the combination notation. Where we have NCR, and that's equal to n factorial divided by r factorial over n minus r factorial. If you're using a spreadsheet or a TI-89, it'll look like C and then N comma R, like that, okay? Spreadsheet, you would have an equal sign with it. Again, though, think about it this way. The N factorial represents your total amount. The R represents your choosing, and then N minus R is what you're not choosing. The 2 numbers in the bottom of the fraction are going to always add up to the top, okay? Now, we use combinations when the order of selection does not matter. We made the assumption that we're going to pick our 5 starters here for our basketball team, and they could play every single one of the positions. So how we selected those, we didn't delineate between forward and power forward and center and so on and so forth. Also, if the items are not unique. Now, it doesn't have to be that the items are exactly the same, is that there's no difference between the items that you're selecting. I know it's a subtle difference, but. So for example, let's say you had 20 students. And you wanted to take 7 to Iceland. How many ways can you make that happen? So we're going to do 20, choose 7. Now your calculator has this capability in it. For those of you